Debugging PHP at the lowest level is not a widespread skill. In fact, what I will show you in this video was news to me and to most of my colleagues. In this video, I'm going to discuss a debugging approach to PHP that my colleague Tim showed us, and I'm fairly certain that you can impress your colleagues with this too. It even requires no PHP extension to be installed and configured, and it does not require you to litter the code with var dump statements. This method is particularly effective to find problems where PHP seems to hang without knowing why. Think infinite loops or code that does just way too much. The tool I'm talking about is GDB, the GNU debugger, and with some dynamically loaded macros, it becomes a powerhouse that you wouldn't expect. Let's go into the example that Tim has thought up in his blog post that I will also link in the description. It's a Fibonacci service, so it calculates the Fibonacci numbers, and with a very large input this can take quite a long time. So we have the Fibonacci service here. We have a server that requires a number parameter to be given. If it's given, we run this with a number and run this service against that. So on my server I have started the PHP local server on port 8888, and then I can run a curl script, for example, against this with any number. Number 7 is the result 13, number 10 is, and then I can see that it will take progressively longer to calculate this. Number 40, for example, already takes quite some time. So how can we debug this? Let's run the curl command again for quite some time. Let's say 44 repetitions. Then we go into a different terminal and we check for any process running with the Fibonacci name in it. So we have the process ID here. Then we start a GDB and then we attach it to the running process. And this is sort of the magic happening here. You see it stops somewhere. In this case, it stops in a tideways hook. We can run the backtrace command and we can see where in the code this hangs the backtrace on the C level. It's in the observer API, which is called by the execute callbacks. So on the server running Tideways and PHP local web server, this is where we stopped the process. So it's not running anymore, it's hanging now. And we can debug the state that it's currently in. So the C stack trace is a little bit boring, or maybe we can't understand exactly what's happening here. Can we see the PHP stack trace? And yes, actually that's possible. We can include a script that ships with the PHP source code. Opening the browser, we see that in the PHP source there's a script .gdb in it, and then you need to find the correct version for your PHP process. So in my case, I have on the server running PHP 8.2. I'm switching to PHP 8.2. And then I can download this script and use this to analyze this running GDB. I already downloaded it in our case. I can source it with this script, and then with this sort of function in GDB source, and then what I can call is the function z_backtrace. And what it will do is it will show me the PHP backtrace. We can see here, it's the PHP backtrace. It's currently running at invoke number 45. So it's like very deep in the recursive Fibonacci number calculation. We can now go and print all local variables of a frame. So for example, let's pick the frame 33 and we can say print, and it will show us the variables here. So n is 33, n1 and n2. We can see are these numbers here. One of them is undefined, the other one is like very large. So we see we are computing this now. This is already computed for this run. And in this run, we are computing this value here. Maybe we want to find out what global variables this script was called with, because maybe the Fibonacci number is way deeper than 445 or something. So we want to find out some information about the global variables. Let's call print global vars, and it will show the different variables here. We have $get post cookie file server and $n. We see n here is 45, but we can also print what the get variable had using print zv, and then we need to specify the memory address of that. And we can see in the get variable we have the key n with the number 45. So this is how the script was called. And this kind of use of those different macros, there are more of them, but it allows you to debug the state of your PHP process using GDB. This was quite powerful, and I was amazed seeing this. I knew that I could run GDB against the PHP process, or running the PHP process started by GDB, but that's clumsy and it's hard to reproduce, especially with web servers. You can't really know how to GDB into a running process. This is even more complicated with PHP FPM, which has lots of children running. So it's hard to get this working. With GDB attach, it's super easy to just attach to a running PHP process or PHP FPM process and then start debugging from there. And then including the macros and having all this information available makes it really powerful to find out what the state of the PHP process is. The only downside really is that you don't have very good breakpoints running. If you attach with the script, it will stop at the point that it's currently at. So it's not as simple as setting a breakpoint and waiting for it to hit. But I guess you can't have everything. If you like this video and PHP performance content in general, please follow this channel, subscribe, and you can also subscribe to our newsletter. The link is in the description. Bye.